This is the lesson for Chapter 8, Section 5, factoring trinomials in the form x squared plus bx plus c. And so it's the second day. So what we're going to see that's different than the first day is that now instead of having a plus sign as the first or the last term, we're going to have a negative sign. So what that means, that minus sign in front of the last terms means that we have opposite signs. And so when we see that, we know we have opposite signs where if we see this sign right here, that plus sign in front of the last term, and the first term is positive as well, we know we have the same sign. So it's nice when you have the same sign because you can figure out what it is. You just look at the middle term, what the outer and inner terms add to make. Like here they're adding to make a positive, so we know both signs are positive. Here we know both signs are negative because they add to make a negative. So with this one, we don't know what the signs are. We just know that one of them is negative and one of them is positive. So when we go ahead and do the work, on a problem like this, I put the signs in last. I don't put a minus and a plus right away. I just start with R and R, and all I know is that the 3, in order for us to get to the 3, we need to subtract. Subtract factors. Factors of 10 in this case. So the factors of 10 that typically we add to make the middle term, now they're going to subtract when we have opposite signs, because opposite signs mean subtract, same signs mean add. So I still do the same thing. I think of numbers that multiply to make 10, like 5 and 2. Those multiply to make 10. But when I check the outside and inside terms, I'm going to see what they subtract to make rather than what they add to make. And so when I do this, I do get them to subtract to make 3r. Now I want to make it a positive 3r. So that tells me I need a positive 5 and a negative 2. And this is where it's real important to make sure that you get the right sign in front of the right term. So when we have more positives than negatives, we need the larger factor to be positive in this case. So we'll go ahead and box that, and we'll move on to the next one. So w squared. Again, minus means we have opposite signs. So I'm going to start with just w and w, and then think of factors of 8. I'm going to try 4 and 2. And when I do that, I have 4w and I have 2w. And so when I do that, I go ahead and subtract, and I do get 2w when I subtract. Now, in order to get a positive, I need the same thing. I need more positives than negatives. So 4w needs to be positive, 2w needs to be negative to make that work. That'll give me a positive 2w. On this one, same sort of thing. We go ahead and see that negative sign from the last term means we have opposite signs. So I have z and z make z squared, and 8 times 5 makes 40. And when I do the subtraction, I do get a 3z. So there's 8z, here's 5z. And in order to get the positive 3, I need a positive 8 and negative 5. So we'll make the 5 negative and the 8 positive. So what's different about these is that these are all negative signs here in front of the middle term. So that means that the bigger factor is going to be negative in this case. So lots of factors of 12. So you got to find the right one. So we need the numbers to subtract to make 4. So we need to make them a little further apart than like 4 and 3. Those would subtract to make 1. So I'm going to try 6 and 2. And you see how that makes 6d. And we have over here the 2d. And those do subtract to make 4d. Now, in order to make it negative this time, I need more negatives than positives. So 6 is negative, and the 2 is positive in this case. Looking at this next one, we have p times by p to make the p squared. And in order to make the negative 8, and since they subtract to make 7, I'm going to try 8 and 1. You see 8 times p makes 8p. And 1 times p makes 1p, and those do subtract to make 7p. Now, in order to make a negative, we're going to make more negatives than positives here, so that will make it a negative 7. So negative 8 right there and a positive 1. And that will end up working out. Well, looking at this one here, we've got numbers that multiply to make 24. So we're going to go with an s and an s to multiply to make s squared. Now, to subtract to make 5, let's try an 8 and a 3. So 8s and we have 3s do subtract to make 5s. Now, in order to make it a negative 5, I'm going to make 3 positive and 8 negative, and that will work out. That'll give us a negative 5s. And so looking at these, now these are different though because we have a plus sign. So we always have to look at that last digit sign to determine what we're going to do, whether we're going to add or subtract the outer and inner terms. So we have W, and they're both the same sign, so we know what the signs are because they add to make a positive. To make 36, let's try 9 times 4 and see if that works. So you add those numbers, 9W, and we have 4W, and those do add to make 13W. So that is the right or the correct factored form. Here we have S times by S to make S squared, but we also know the sign already because both are negative. So numbers that multiply to make 32, let's try, well, 8 and 4 are going to end up adding to make 12, so let's try those. So 8S, that's a negative 8S, and we have a negative 4S, and yes, those do add to make negative 12S, so it does work out. So again, it's critical to look at that last digit sign to determine what you're going to do. So to make a 17V, V squared minus 17V plus 60. So we know both signs are negative. To multiply to make a positive and add to make a negative. And when I think of factors of 60, typically I think of 10 and 6. But those aren't working because 10 times by 6 multiplies to make 60, but those add to make 16. So I would need to break this down, see if we can find some other ways to multiply to make 16. So something that I do see, though, they need to be a little further apart than 10 and 6. So I'm going to try, let's break this down to 5 and 2, and then 2 and 3. And then try to find a way to make the numbers a little bit bigger. So for instance, I can multiply all these numbers, 2, 2, and 5. That would be 20 times 3, but that would make 23. If I do 15 times by 2, that's going to, or 15 times by 3, that would give me, let's see, actually 15 times 4, that would give me 60 as well, but those do to add to make 17. So let's go ahead and write that down there, 4 there, and that adds to make 19 rather than 17. So in this case, this one probably doesn't have any factors that end up working out because of this plus sign here. They have to be the same sign. So if we go ahead and 15 and 4 don't work out because those are a little bit too big. This multiplies to make 60, but it adds to make 19 rather than 17. So we need to make them a little smaller. So let's try taking all these numbers right here. Now I know 15 and 4 don't work, so I'm going to try 4 times 4 times 3 makes 12, times by 5 does make 60 as well. This is the one that's going to work out. So we have negative 12V, and we've got negative 5V, and those two do add to make negative 17V. So we finally figured it out. So let's take a look at the other types that we might end up seeing, and it looks like we've got an area problem here. It says that the area of a rectangular door is given by this trinomial, and the door's width is x minus 9. What's the length? Well, we've already got one of the factors. We know that 1 is going to be x minus 9. Looking at the polynomial, since they're the same sign, because they multiply to make a positive, I know it has to be a negative. And 9 times 5 is the only number that makes 45, so let's see if it works. 9x and 5x, those do add to make negative 14x, so that's it. So what is the door's length? We would say x minus 5 units is what I would end up saying there. And moving on to this next one, it says that the area of a rectangular painting is given by this trinomial. One of the length is a plus 2, so we already know a plus 2 is the length, so to find the width, the numbers need to be opposite in sign, so it's going to be an a minus. 2 times 8 makes 16. Let's see if those add, though, to make negative 6. So this is 2a, negative 8a, yes, they just make it negative 6a. So a minus 8, that is the units, that is the width of the painting. Over here, just a little bit tougher because we have the n squared at the end. So again, we have k times by k multiplies to make k squared. Now the tough thing is we got to find factors of 96. So I'm going to take 96 and I'm going to break that down. What I think of real quick is 12 times by 9 multiplies to make 96. But I need them to subtract because they're opposite in sign. is subtract to make 4. And you see these only subtract to make 3. So I need to break these down a little bit further. So I've got 3, 3, 3, and 4. And what I need to do is I need to get them a little further apart. And so I need to make a number bigger than 12. And so when I look at that, I can see that I've got 4. Let's break this down a little bit further here. 2 times 2 times 3 makes the 12. So let's take the 2, 2. How about 2, 3, and 3? Let's try that. So let's do 2, 3, and 3. That makes 9 times 2 is 18. And then I'm left with the 2 and the 3 here, so that makes 6. So 6 times the 18 also makes this 96. Let's see, that's 48. So let's check that again. 3 times 3 and 2 times 2, because that's 48. Alright, so my error here is that 9 times 12 doesn't make 96. It's 8. So let's change that real quick. And so when I tried that, it wasn't working, so I had to think of other things that would work. And 8 times 12 does make 96, and those will subtract to make 4, so let's put those in there. And it's going to be a 12n and an 8n. And so in order to make it work, I'm going to end up needing to make this one positive, this one negative. Let's see if it does. 12nk, and then a minus 8nk. And yes, those are going to end up making that 4nk, positive 4nk. So that is the correct answer. Over here, I know it's going to end up being starting with a g and a g to make g squared, and I'm lucky it's a positive sign for that last term. That means I know both signs are negative because they add to make a negative. To make a 13, so they're adding this time to make 13, so it's going to be 7h and 6h. Those add to make 13. Let's see if it works out. So negative 7hg and a negative 6hg, and those make negative 13hg, which matches the negative 13gh, and so that is our answer. Look at the last one. It's a negative sign for the last term, so they have to subtract. The outer and inner terms are subtracting now, so we have m and m make m squared. I know n and n make n squared, so I just need to find the numbers that multiply to make 32. So let's try 8 and 4 multiply to make 32. And when I do this work, I've got 8mn, I've got 4mn for the last terms there. And sure enough, those do subtract to make negative 4 if I make the 8 negative and the 4 positive. And that does end up working out. Well, let's take a look at the last one here. It says, describe and correct the error made in the factoring. Well, I see that they are x and x make x squared. 8 times negative 10 does make negative 80. But if you look at the outside and inside terms, this makes negative 10x, this makes a positive 8x, and that adds to make a negative 2x. And look what sign they have. It should be a positive. So what we did wrong here is we have the wrong signs. We need to make the 8 negative, and we need to make the 10 positive. And you see, if we do that, it'll become, again, x squared. It'll be a positive 10x. It'll be a negative 8x, and it'll be a negative 80. So you see, we still have the negative 80, still have the x squared, but then when we combine these two terms, we get a positive rather than a negative. And so if you're ever off by just your sign, that means your signs are switched. All right, so those are the types of problems that you'll see on tonight's homework. Good luck.